Your first customer support agent receives this message: I was charged twice. The large language model, or LLM, decides the user sounds angry, writes a polite apology, calls a refund tool with a guest order ID, and marks the ticket solved. In your demo, it looked smart. In production, accounting now has a bad refund, support has no extracted charge amount, and the customer still needs help. The model did not simply fail because it was dumb. You asked it to classify sentiment, extract fields, decide policy, call a tool, and write a reply in one breath. The beginner move is one mega prompt. Here is the user message, the policy, the tool list, the output format, and the tone guide. Now solve it. Sometimes it works, which makes it dangerous. When it fails, you cannot tell which part failed. Did the model misunderstand the category, miss a date, invent a policy, choose the wrong tool, or produce malformed JavaScript object notation JSON? You have one blob of text and one messy result. That is not an agent design. It is gambling with a nicer interface. Capability mismatch is behind a lot of early disappointment. Before blaming model quality, ask whether the call had one clear job. Think of LLM capabilities as task shapes. Classification asks, which bucket does this belong in? Extraction asks, what exact fields are present? Writing asks, produce useful language for a reader. Summarization compresses while preserving the important parts. Coding transforms requirements into source code, usually with review. Planning creates a candidate sequence of steps. Tool selection chooses which external function, if any, should run. These are not equally reliable, and they should not be treated the same. My practical rule is simple. Choose the smallest capability that can move the workflow forward. A cheap, boring classification call can save you from a dramatic, expensive failure later. Build the workflow as small calls with typed boundaries. Step 1. Classify the request. Maybe billing, bug, sales, or other. Step 2. Extract the fields needed for that class, using a schema like order ID, amount, date, and issue. Step 3. Validate the extracted fields with normal code. Missing order ID is not an LLM mystery. It is a missing value. Step 4. Only then ask for a plan or a tool choice. Step 5. After tool results return, ask the model to write the response. Notice the shape. Classify, then extract, then validate, then act, then write. Each call has one job and a checkable output. Suppose the user writes, I ordered the blue headphones last Friday, order A123, and I see 2 charges for $79. Please fix it. A mega prompt might apologize and promise a refund before checking anything. A capability-matched flow starts with classification, billing issue. Next extraction returns order ID A123, product blue headphones, amount $79, claim duplicate charge, date last Friday. Your code checks that order ID exists, and amount is a number. A tool lookup can then fetch real payment records. Only after that do you ask the model to write. If records confirm one charge, the reply is different from duplicate charge confirmed. Writing is last, because facts should not come from style. This design improves reliability. It does not make models flawless. Classification can be ambiguous. Extraction can miss a field that is implied but not stated. Summaries are strong for reducing text, but they can drop the one detail your downstream code needed. Planning is useful, especially for brainstorming steps, but it is not a proof that the steps are valid. Tool selection is helpful, never sacred. Always allow no tool or needs more info. And yes, structured output can still drift, especially with weak prompts, long context, or older models. Use schemas, retries, and validation. The trap tutorial skip is assuming a pretty plan means the agent is competent. This episode sits right before prompt engineering gets interesting. If you do not know which capability you are asking for, better wording only hides the problem. Later in the series, we will cover context windows, structured outputs, tool calling, state, memory, and model selection. All of those depend on this foundation. An agent is not one magic prompt. It is a harness around a goal, a role, tools, permissions, state, and termination rules. LLM calls are components inside that harness. Some calls classify, some extract, some plan, some write. The reliability comes from arranging those capabilities with checks between them, not from hoping the next model reads your mind. Here is a safe 10-minute exercise you can run locally with no third-party systems. Create 12 fake support tickets in a text file. Include billing, bug report, account access, sales question, and nonsense. Write a tiny Python script with 3 functions: classify ticket text, extract fields text, label, and draft reply text fields. Use whatever LLM application programming interface or API you already have, or mock the calls by hand first. Print the label, extracted fields, and any missing required fields before drafting the reply. The point is not a perfect chatbot. The point is to feel the difference between one giant request and a small pipeline you can inspect. 3 beats to take with you. First, LLM capabilities are different tools, not one undifferentiated smartness knob. Classification and extraction are the underrated workhorses of reliable agents. Second, writing and summarizing are strong, but facts need downstream verification when the stakes matter. Third, planning and tool selection are useful, but you must design for misses with validation, no tool paths, and human or code checks where appropriate. Match the task to the capability before blaming the model. Tomorrow we keep building the foundation with prompts that specify the job without turning into a wall of wishful thinking. New Agent Foundations episode daily. The paid libraries at aislabs.ai go deeper.